Hello all. We move ahead again with integration, definite integration CET. Okay. All set for the next lecture? Fine. How are your studies going on? अच्छा चल रहा है सब? As I told you, practice for 2 hours, 2 to 3 hours only maths, physics and chemistry because the exams are near now. Okay. So without wasting any time, let us go to definite integration, two important sums and three important problems where when you use those formulae, three important formulae, when you use those formulae you don't have to make substitution, directly you can use those formulae. So let us see the formulae first. Okay, now all these formulae have function and derivative in them. एक इंटीग्रल में फंक्शन है और डेरिवेटिव है. फॉर एग्जाम्पल ओवर हियर f dash x upon fx. fx is the function, f dash x is the derivative. Without making any substitution, answer is log of fx. But you should be careful. f dash x ऊपर चाहिए. For example, sec squared x upon tan x. Tan x is the function. Derivative of tan x is sec squared x. So f dash x upon fx, log of fx, that is log of tan x. Log of the function. Okay, straight away you can write the answer. These formulae are specially very important for CET sums. Okay, then f dash x into fx raised to n. Again a combination of f dash x and fx. हर एक में combination है, f dash x upon fx, f dash x fx. Now here it is f dash x into fx. So f dash x और fx का combination है. This formula we have not used for board, but let's see how to use that over here. So when both f dash x and fx are present side by side and you have fx raised to n, the answer is fx raised to n plus 1 upon n plus 1. As simple as that. Again I am repeating. When f dash x derivative and function are present side by side with a multiplication sign, ऊपर डिवीजन साइन था, then the answer is fx raised to n plus 1 upon n plus 1. Okay, for example, side by side function और डेरिवेटिव क्या है देखो, sec squared x tan x, fx, function is tan x, derivative of tan x, f dash x, right? So side by side है दोनों. What is the answer? fx raised to n plus 1. Now what is fx? tan x. तो tan x के ऊपर क्या है अभी इधर 1 है. So tan x raised to n plus 1 means 1 plus 1 upon 1 plus 1. Followed? अगर यहाँ पे tan squared x रहता तो tan x raised to 2 plus 1 upon 2 plus 1. Nothing is present here, so n is equal to 1. So fx raised to n plus 1 upon n plus 1 means tan x raised to 1 plus 1 upon 1 plus 1. Means what? 1 plus 1 is tan squared x upon 2. Followed? Fx raised to n plus 1 upon n plus 1. But when the functions are present side by side, function and derivative. And thirdly, again, quotient है, denominator, f dash x upon the root of fx. In the earlier sum it was f dash x upon fx log of fx. But f dash x upon the root of fx you get 2 root fx plus c. For example, sec squared x upon the root of tan x, 2 root tan x plus c. Now I am surprised that in most books first two formulae are mentioned, but third formula is not mentioned in some books. Okay, but that is equally important. अगर रूट साइन है तो 2 root fx plus c. अगर रूट साइन नहीं है तो log of fx. Clear? Now इसका यूज ये प्रॉब्लम में होने वाला है. So let's straight away go to the problem now. This particular sum is CET PYQ 2018, लेकिन उसके पहले 2015 में जेई में पूछा था. integral tan cube x dx. Now, whenever we get tan cube x, it is always better to separate out one tan x. एक tan x बाजू को निकाला. What remains is tan squared x. From tan cube x, if I take tan x aside, what remains is square. Tan squared x remains. Okay? So why do you think we have done this? Simply because tan squared x can be written as sec squared x minus 1. Okay? Identity. तो ये कन्वर्ट करने की जरूरत क्या है? Because as soon as I get sec squared x, I get tan x is the function, sec squared x is the derivative. fx and f dash x लाने के लिए tan x सेपरेट किया, tan squared x को sec squared x minus 1 किया, and then separate out sec squared x tan x, see multiply sec squared x tan x, separate out the integrals also, minus integral of 1 into tan x is tan x. Just open up the brackets and separate out the integrals. Okay? So remember this rule. Rule nahi, ek obvious thing that you have to separate one tan x in order to use this identity. Okay. Now let us solve both. साथ में simultaneously solve करेंगे. अभी देखो, in the board exam, we used to say let tan x equal to t, sec squared x dx equal to dt. Change the upper limit and lower limit. New upper limit, new lower limit. After substitution करना पड़ता है ना. लेकिन अभी देखो, you have a formula f dash x into fx is equal to fx raised to n plus 1 upon n plus 1. So naturally sec squared x into tan x, यहाँ पे लिखा है example, sec squared x into tan x, tan squared x upon 2. I explained why. So according to this formula, f dash x into fx का इंटीग्रल क्या है? fx raised to n plus 1 upon n plus 1. अभी ऊपर 1 है. So tan squared x upon 2. I have already taken that example. As soon as you write the answer, you have to put the upper and lower limit. So there is one more use. Time save हो जाता है. Put tan x equal to t. Secondly, you don't have to change the upper and lower limit. Keep them as they are. कोई जरूरत नहीं. Fast हो जाता है. Integral of tan formula, basic formula. Integral of tan x is log of sec x. You know the basic thing now. Upper limit minus lower limit. So take 1 by 2 outside. Constant बाहर देखो. In place of x, put upper limit. In place of x, put lower limit. Lower limit is 0. Similarly here. Function वैसा ही है, log remains as it is. Only in place of x put upper limit. Log of sec of pi by 4 minus log of sec of 0. Log of sec upper limit minus log of sec lower limit. Usual. Now tan pi by 4 is 1. So I get 1 squared. Tan 45 is 1. Tan 0 is 0. pi by 4 is 45. Cos 45 is 1 upon root 2. Sec 45 is root 2 upon 1 or root 2. Cos 0 and sec 0 are 1. Sec 0 is 1. Log of 1 is 0. यहाँ पे सिर्फ आई एम ओनली राइटिंग 1, नॉट राइटिंग 0. Okay. Log 1 is 0. Neglect that. Only this remains. Log 1 is 0. I'm not writing that. So now, how will you convert into any one of the four options? First thing is, I got half here, right? So I will call this as 2 raised to half. Okay, half into 1 is half. Two raised to half. Okay, take this half in front. So the thinking process is I'm trying to simplify because I'm having half here. I'll try to get half there, and half comes in front by the rules of logs. Take out half common. One minus log 2. Next thinking process. सब जगह पे log है. For all four options we have got log. So remember, now to convert the answer into, you already have got log here. So I want to get log here also, because otherwise you won't get the answer in terms of logs. ये answer आ गया. Board में अगर है तो this answer would have been given correct. But you have to simplify to get this answer. So now my thinking process is I will get log here. So बोलो कैसे log है log? Simple. Log of E is 1. हो गया? Then log A minus log B. Log A minus log B. Log of A upon B. अब एक सिंपल चीज करो. Take this half again above, because अभी इसका कुछ काम नहीं है. So again I am taking the half above. Because all four options contain only log. What is x raised to half? Root x. So e by 2 raised to half कितना है? Root of e by 2. Okay, this is our answer that we have got. Let us check कौन सा ऑप्शन सिलेक्ट करेंगे. Unfortunately, e by 2 is not present anywhere. So what should be your last thinking process? Today I am concentrating on your thinking processes. क्या रहेगा? पहला, first thing is everything is okay, but I need to get 2 above and e below. Because e by 2 नहीं है, लेकिन 2 by e आया ना इधर, यहाँ पे भी है. So yesterday we saw that when we interchange this, लॉग के सामने जब फ्रैक्शन इंटरचेंज करते हो न्यूमरेटर डिनोमिनेटर तो क्या हो जाता है, साइन चेंजेस, लॉग बिकम्स माइनस लॉग. अभी चेक करो ऑप्शन, माइनस लॉग 2/e root, of course root is there. Check the option. Okay, even if root is there, don't worry, you are interchanging the fraction, sign of the log changes. So minus log of root of 2/e है क्या? This is our answer. Followed? Interesting sum. Thinking process मैंने बता दिया अभी, because this needed certain things for you to follow, but in CET all these things have to be done fast. Tan pi by 4 minus tan 0 to directly, this thing can be done orally also. I'll just tell you the method how to do it orally for CET. CET में, now this has, after this step there are no shortcuts, you have to work it out fast. तो orally कैसे करोगे देखो, half constant bar, this you have to do orally, upper limit, tan squared pi by 4, tan pi by 4 is 1, minus lower limit, tan squared 0, 0. All this has to be done orally, नहीं तो टाइम ही नहीं मिलेगा पेपर सॉल्व करने के लिए. माइनस do this orally. Upper limit, sec of pi by 4, sec 45 root 2, minus lower limit, log of sec 0, ये orally करना. Log of sec 0 means sec 0 cos 0 is 1. So log of 1 is 0. So directly you can write 1 into 1, 1/2 minus log root 2. यहाँ पे आया ना 1/2 minus log root 2, and then your thinking process as to how to convert. Followed? Interesting sum. I also loved this explaining. Challenging था. So try to solve this again. Okay. If time permits, I'll take one more problem. Come on. ये पहले लिख के लो. Let's see. Okay. Let's go to one more sum. Another interesting one. Important one. 2 बार पूछा था. Integral root of cos theta sin cube theta d theta. Sin cube आया, like in the earlier case. I said whenever we get cube, separate out one sin theta. What remains is sin squared theta, like we did in the earlier case. Except उधर sin cube नहीं था, something else was there. So sin squared अलग रखो, separate sin theta. Why do I do this? Because for sin squared, immediately write 1 minus cos squared. Why do I do that? Because cos is present. I want to get one more cos, so that substitution will be simple. Why? Let us see. So this I am going to write as bracket 1 minus cos square theta. ये sin theta को ऐसे ही रखना है. Now function is there, sin theta is the function, cos theta is the derivative, but in this case we are not able to use any of this formulae because यहाँ पे f dash x into fx है, वैसा फॉर्म नहीं आ गया इधर. So now we have no choice but to make the substitution. This form reduces substitution. यहाँ पे there is no alternative but make a substitution. क्या करोगे अभी देखो, put cos theta equal to t. Now it is your choice, differentiate with respect to theta if you want, or differentiate with respect to t. It's your choice. Okay. So if I differentiate with respect to theta, d by d theta of cos theta का मीनिंग क्या है? डेरिवेटिव ऑफ cos theta with respect to theta is minus sin theta. d by d theta of cos theta. d by d theta of t is what? dt by d theta. Now this has to be done orally, directly. Cross multiply. I'll do it here. Check करो. I want only sin theta d theta. So keep sin theta d theta on the left hand side, minus sign on the RHS. Cos theta equal to t. And now it is definite integration, so you have to change the limits. Upper and lower limits will change because of the substitution. In the earlier case, substitution was avoided, so limits were not changed. Now, how do you change the limits? Write the original substitution, cos theta equal to t. डायरेक्टली करना है. ओरिजिनल अपर लिमिट पाई बाय 2. t is equal to cos pi by 2. In place of theta, put the original upper limit. Cos 90 is 0. अपर लिमिट चेंज हो गया, यहाँ पे 0 आ गया. अभी देखो cos 90, ये सब्स्टिट्यूशन में पुट थीटा इक्वल टू पाई बाय 2 टू चेंज द लिमिट. सो cos 90 is 0, so you get 0. I'll write here. चेंज हो गया. Then same thing. Put theta equal to 0. Cos 0 is 1. तो ये भी चेंज हो गया. So let us make the substitutions now. Integral I equal to cos 0 has got converted into 1. Cos 90 has got converted into 0. Cos theta is t, so root of t (1 minus t squared). Sin theta d theta कितना है? We already have got somewhere. Sin theta d theta is minus dt. Take the minus sign outside the integral. यहाँ पे बाहर ले लो. Do one more thing. Root of t is t raised to half. 1 minus t squared. Minus sign has gone outside. अभी दोस्तों और एक चीज करनी है to make the calculation simpler. When you remove the negative sign, when the sign of the integral changes, upper and lower limit also changes. There is no hard and fast rule कि sign बदलनी है, but it is better to change this into plus to make calculation simpler. So what I'll do is minus sign को plus किया उधर, minus sign चला गया. So when the minus sign goes, upper and lower limit interchange. At the same time brackets open up करो, t raised to half into 1 is t raised to half minus t raised to half into t squared. Orally, laws of indices what happens, हाफ प्लस 2 हो जाता है. अभी हाफ प्लस 2 आप कैलकुलेट करो, इट विल गिव यू 5/2, t रेस टू 5/2, और यहाँ पे dt है. सो लिमिट्स इंटरचेंज हो गया है. t रेस टू हाफ माइनस t रेस टू हाफ प्लस 2. फिनिश ऑफ द सम ना. इंटीग्रल सेपरेट करो. इंटीग्रल सेपरेट करो. 0 to 1, हर एक के साथ dt आएगा. अगेन 0 to 1, बेसिक फॉर्मूला. x रेस टू n का फॉर्मूला क्या है, x रेस टू n प्लस 1 अपॉन n प्लस 1. सो t रेस टू हाफ प्लस 1 अपॉन हाफ प्लस 1. नाउ इन CET डोंट राइट ऑल दिस. हाफ प्लस 1 को डायरेक्टली ऐसे लिखो, 3/2, t रेस टू 3/2 अपॉन 3/2. ये भी ओरली करो. t रेस टू 5/2 प्लस 1 अपॉन 5/2 प्लस 1. 5/2 प्लस 1 is 7/2. अभी क्या करना है, 3/2 को ऊपर लेना, उसका रेसिप्रोकल हो जाएगा. 2/3, 0 to 1 है. 2/3, 3/2 नहीं बाहर आ गया, 2/3 उल्टा होके ऊपर आ गया. अपर लिमिट 1 रेस टू 3/2 माइनस लोअर लिमिट 0 रेस टू 3/2. 7/2 का रेसिप्रोकल 2/7 कम्स आउटसाइड. ऊपर 2/7 बाहर निकाला है. 1 रेस टू 7/2 minus 0 raised to 7/2. Now remember one important rule. 1 raised to anything is 1, even if it is a fraction. So 2/3 into 1. 0 लिखने की जरूरत ही नहीं है. 2/7 into 1. Come on, last step. 2/3 minus 2/7. 3 and 7 का LCM 21. 3 7s are 21. 2 7s are 14. 7 3s are 21. 2 3s are 6. 14 minus 6. That is the correct option given. One more interesting sum. So sometimes the problems you have to use the basic methods. Only shortcut for such thing is your brain. If your basics are perfect, some things, as I told you, have to be done orally. You have no choice. उसके लिए practice की जरूरत है. I am sure you followed all this, right? So try to solve this within a very short period of time. Try करो और एक बार, right? So that will be all for today. कल देखेंगे अभी. Good night from here. Bye.